welcome to the 10th lecture. We have been discussing about the two particle or the two body system. So, we will continue with that. So, last time if you remember we were working one problem also, and then we discussed some theory also. So, few things related to that theory whatever we have done. So, we will discuss again before we take up the original subject. So, if this is a circular orbit and there is a particle here which is moving in this circular orbit. Okay. So, as per our discussion, we have got r double dot minus theta dot square r this equal to f r and r square theta dot this equal to h. This is what we have derived. Okay. So, if particle is moving in circular orbit, then r is equal to a constant, and therefore, this implies r double dot this will be 0. So, this equation then gets reduced to r times theta dot square with minus sign this equal to f r. So, this is moving under gravitational attraction. So, from here we are trying to find out what will be the rule for gravitational acceleration if the particle is moving under this gravitational acceleration in a circular orbit. So, this is circular orbit. This is circle. Okay. So, theta, now we will utilize this equation and insert it here. So, r times theta dot equal to h by r square, this is whole square equal to f r, and this implies f r equal to h square divided by r cube. Okay. And as we have written h square equal to mu times L. So, this is, and this will be say minus sign here, minus sign here. Also, we have derived that r equal to L by 1 plus E cos theta. So, here in this case, in the case of a circle, E equal to 0, and this implies r will be equal to L. So, if we insert here in this place, then this is minus mu r by r cube. So, this is minus mu by r square. So, this gets reduced to your usual inverse square law. So, that means, if a particle is moving in a circle and this force is toward the center, okay, and particle is moving in a circle. So, that is bound to be the inverse square law, which is your gravitational force equation that you write or F equal to m1 m2 g divided by r square with a minus sign you are writing. So, here F by m if we divide. So, this is the unit which is being taken here, this is per unit mass. So, maybe if we can change it. So, F by m equal to F, this gets reduced to m1 will divide it by m1 or either m2 let us divide by m2. So, this is minus m1 g divided by r square, which is nothing but minus mu by r square. So, this is therefore, F equal to minus mu by r square. Okay, so, using this rule we can work out any problem. So, this equation constitutes your basics of the central force motion. this has nothing to do with the this gravitational force or any other thing. This is just central force motion, and depending on what kind of the function f r is, so the whole thing will your orbit will determine. It will on that your orbit will depend. Okay, so, in this context we take up one more problem, okay, and thereafter we will go to the theory. So, we have here so that mu by r square. Here attraction it is written, so only mu by r square. Actually, we should put a minus sign here. So, that we will do later on. Under the once we are writing attraction means it is always this will be negative. So, this is what we need to prove. So, what is here this part is your radial velocity. So, we can divide by this r square here and this will be mu by a r square. So, this is the expression for the radial velocity. So, we start with the same condition what we have got r double dot minus theta dot square r, this equal to f r, which in this case is given to be minus mu by r square, because this is attraction. Okay. Attraction means it is directed toward the center, and therefore, minus sign will come. This is positive direction of r and this is negative direction of r. Okay. So, in this direction this is negative r, positive r. Okay. So, we are putting a minus sign to indicate this is attraction. And another equation we have r square theta dot this equal to h. So, we insert here in the upper equation. So, r double dot minus theta dot is h by r square by whole square. So, r square and here r is there. So, we will put this r, this equal to minus mu by r square, and this implies r cube, this equal to minus mu by r square. So, see the in the question it is asking for computing the radial velocity, means it is asking what is r dot. So, we have to work out r dot, but here the expression we are getting after combining this a and b, okay, we are getting this expression c. In expression c, nowhere we have r dot, so r double dot is present. So, we need to integrate it once in order to get r dot. So, multiplying equation multiplying equation C by, now see here one thing we can guess from this place, if we try to integrate it. So, so this r double dot, this must come from r dot square. So, if we differentiate this, so this will result in 2 r dot times r double dot. Okay. So, what we will do, that we will multiply it with 2 r dot, okay, and then integrate it, so that after integration we get this quantity. Okay. So, multiplying equation C on both sides, C on both sides by 2 r dot. Okay, and this technique you should remember, where we are taking, you might be seeing that quite often we have been using dot product with r dot or cross product with r. Here I am taking simply multiplying with 2 r dot. So, these are the techniques of solving the problem. Okay, and if you remember these techniques, so you may be able to solve a number of problems which will be in your exercise. So, we get 2 r dot times r double dot, and then we have minus h square by r cube minus 2 r dot h square by r cube, and then we have minus mu by r square 2 r dot mu by r square. So, integrating equation D. So, if we integrate it, so 2 r dot r double dot minus h square will take outside, h square 2 r dot by r cube, and this will be equal to minus mu 2 r dot by r square and plus c, which is a constant, or let us okay, we will keep this as c only. So, this is e. So, this is a constant. So, if we integrate it, as I told you, we can write this as d by dt r dot square. Okay. This will be minus h square, and here if we see, this will be d by dt 1 by r square. So, we will explore this term, and what will be the sign here in this place. So, we are going to explore it. So, we will do some rough work. We can do here on the bottom itself, d by dt 1 by r square. So, this will be d by dt r to the power minus 2. So, once we differentiate this, this will be minus 2 here, and then r to the power minus 3 times r dot. So, this gives us minus 2 r dot by r cube. Okay. So, this way this that means this minus sign should be fetched inside. So, here instead of putting it minus, we put it plus here, and minus sign we fetch it here in this place. Okay. And on the right hand side, this is rough work. Again on this side, we have to look into this, what the result will be. So, for that we need to go on the next page and work it out, and then I will return back to this place. So, this is 2 r dot by r square. Two r dot by r square, 2 r dot by r square, this is integration. So, we take 2 outside. If we write d by dt, okay, forget this. If we take the quantity 1 by r here, d by dt 1 by r, okay, these 2 also will remove, and then check that what we are getting here in this space if we break it. So, this will be minus 1 by r square times r dot. So, this is nothing but your r dot minus by r square, while here you have 2 r dot by r square. Okay. So, this is your again rough work. So, here in this case, this becomes minus 2 mu, or this is the minus sign is appearing here if we differentiate this 1 by r. So, if you now integrate it, see here in this case what we are doing, that once we have written it like this, on the right hand side also we will write in the proper way minus 2 mu. So, this is 1 by r d by dt minus 1 by plus 1 by r. So, if we write it in this way, okay. So, from here if we differentiate, this is minus 1 by r square r dot, okay. 2 is already there, mu is already there. So, this minus sign should get to plus, and here we have c. Now, we can integrate this expression. Okay. One more thing is required to do here in this place is that we have to see, once what we are doing, that we are trying to differentiate this. So, once we have to remove this integral sign, so what we need to do? This is the question here. So, I will copy the expression from the previous page here, and thereafter we will work. This is d by dt integration r dot square Okay, plus h square dy dt okay, here if we differentiate it, so that becomes plus. So, here the we have done the mistake here, just the minus sign. See, once we are absorbing the minus sign here, okay. So, this place what we are doing, that if we differentiate it, so we can see that this will be minus 1 by r cube. We have done this work here somewhere. This is in this place. So, once dy dt 1 by r square we are doing. So, dy dt r to the power minus 2. So, this is coming in this way. Okay. This is minus 2 r cube divided by times r dot. So, finally, we are getting this expression. So, that means already if we differentiate this, so we get a minus sign here. So, I need not take here in this place, we will not take a minus sign here in this place, and in this place we will put a, then we will put a plus sign. It is not that we absorb it here and then putting that way. Now, you can see the quantity here which is present here, if I differentiate this. So, this is the way we are writing. So, this minus sign here appears, this is the minus sign. So, this minus sign will ultimately manifest here in this place. Okay. So, now this is okay, and on this side also we have written it the same way. So, once we differentiate it, so this quantity, then the minus sign will appear in this place. So, and one more thing we will do, let us first remove this integration sign, first we are removing, okay. And this c also will remove to make it more consistent. This is removed. So, you can look now that this part, this particular expression, this can be written like this. Okay. Similarly, this with this whole with minus sign can be written as this one, okay, with whole this plus sign, okay, because once we differentiate it, this integration sign also will not be present, this we have to remove, okay. And here also we are removing the integration sign, this c also will remove. So, once we are working out like this, so you can see that if we just operate this differential operator, okay, so this quantity will result, the upper equation E will result. So, this equation will name as, this is your equation number E, this is F. Now, we can do the integration with respect to dt. Okay. On both sides we can operate with respect to dt, this is the proper way of doing it. So, now we go to the next page. So, on the next page then we have remove this sign first, here integrate it with respect to dt plus h square 1 by r square dt h square. So, this quantity we are integrating, then this is 2 mu integration sign d by dt 1 by r d by dt 1 by r dt, and then the constant sign will be introduced. So, this is the way of doing it. Okay. So, this dt can be removed from this place. Okay, and a simple way this we can write as r dot square plus h square by r square, this equal to 2 mu divided by r plus c. So, this is the integration. So, this is f and this is equation number g. So, now this r dot, this is appearing as the radial velocity. So, remember the step to work it out. Here it is I was trying to do here, I could have put here dt itself and putting the integration sign, because we have to integrate it with respect to dt, but I have taken one more step for working it out. So, that is better. Okay. In doing the shortcut, quite often we do some mistakes. So, it is better that we go step by step. Now, this is the quantity we were looking for. Okay. So, can we evaluate it? Once we can evaluate it, so our job is done. So, now we have v square equal to r dot square plus r times theta dot square. This is the radial velocity and this is the normal velocity as we have discussed earlier. So, this is r dot square plus r square theta dot square. Okay. And here we can see that this is r dot square and we can replace theta dot by h by r square, our expression we have used earlier. So, this gets reduced to r dot square plus h by r square. This is a square term. This whole square. Okay. So, with this we can recognize that left hand side is nothing but here v square. So, we go to the next page. So, equation g can be rewritten as v square equal to 2 mu by r plus c. And if this c, the constant c is known, if this constant is known, so we will be able to work out the whole problem. Now, also we will utilize one relationship, this v square, which we are going to prove it later on, perhaps till now I have not done it. V square equal to mu times 2 by r minus a, means this is 2 mu by r minus mu a. So, if we compare these two, this is equation number h, this is I. So, if we compare, so this c turns out to be from this place c equal to minus mu a. Okay. So, therefore, we have now, so either we could have, if we use this equation, so we can start at this stage itself. So, now pick up from this place r dot plus h square by r square, this r dot square therefore, this is 2 mu by r and c equal to minus mu a. Sorry, here this part is we have written the 2 mu by this is 1 by a. So, this gets reduced to mu by a. Mu by a. So, this is mu by a, c equal to minus mu by a. So, here I will correct it. So, this gets reduced into the form. So, directly if we know this equation, if we remember this equation, okay, we can directly work out from this place. So, here this is, then this implies r dot square r square equal to and plus h square equal to 2 mu r, taking r square on this side minus mu r square divided by a. Or r dot square r square a plus h square a equal to 2 mu r a minus mu r square, and the rest of the things we will take it on the right hand side. So, r dot square what we were looking for this expression. So, r dot square r square as in our question this is. So, r dot square r square this then becomes 2 mu r a divided by a minus mu r square and then minus h square a, here it will be minus h square a divided by a. So, if you look back, mu has been taken as a common throughout. Okay. We are missing some term here. H square this is okay. This is fine. A we will take outside and mu also we will take outside. So, mu by a as it is required in the problem. So, 2 r a minus r square, and here this is given to be mu we are taking it outside. So, h square a cancels out. Okay, so, h square a is there on the previous side, this h square a. So, this is a cancels out and we get here, but we are taking a here. So, we will keep a here in this place like this. So, let us work like this, 2 r a minus r square and h square. In the problem if you look, h square is nowhere mentioned. If you go back on the previous page, here here nowhere h term is appearing in this equation. So, we have to eliminate h from that place. So, h square now as we remember h square equal to mu times L. So, we write here mu, okay, and mu we have taken outside. So, we have to divide it by mu here in this place. Okay. So, this once we work out A cancels out h square, this is fine. So, you can check yourself, this satisfies the this can be reduced to this format. So, now h square by mu, this is L. So, remove this part from this place. So, this is L A, L times A. So, this is mu A times 2 R A minus R A square. Now, L as we have worked out earlier, this is 1 minus E A square. So, this is mu by A 2 R A minus R A square minus A square 1 minus E A square. So, this is R square R dot square, but still the right hand side it does not look like what it is given in the problem. So, what we will do, rather than breaking it and spending our energy, we will just take the right hand side of the problem itself and reduce it to see whether it matches with this one or not. So, in the actual expression, the right hand side is mu by A times 1 plus E minus R, and then R minus A times 1 minus E expand it. So, we will reorganize it 1 plus E minus R, so that we can multiply it in a better way, A times 1 minus E minus R, and minus sign we will put here for the time being. So, this becomes A square 1 minus E A square minus A R times 1 plus E minus A R times 1 minus E and plus R square. One minus E A square minus A R minus A plus E times R. So, the A R 1 plus E, this is okay. So, A R minus A R E, from here this place minus this is A R and plus A R E and plus R square. So, the terms here, this one and this one, they will drop out, leaving us with minus mu by A square times 1 minus E A square minus 2 A R plus R square. So, this is your RHS. If we take the minus sign inside, so this gets reduced to 2 A R minus R square minus A square 1 minus E square. So, now we will match with the what we have derived earlier. So, here mu by A 2 A R minus R square minus A square times 1 minus E square. So, the same thing is here. Okay. So, therefore, whatever we wanted to prove, this has been proved. So, the radial velocity is related by this expression. So, little bit of change in this particular part. So, R dot square we can write as mu by A R square and times this whole thing, the bracket thing should be copied here in this place. So, R dot square equal to mu by A square and this quantity appears here. So, we have started solving this problem in the two particle system. So, this was our problem here. and ultimately we have got the result, but at one stage we have used one information which I have not done still. Okay, V a square equal to mu times 2 by r minus 1 by a, and this particular part, this is also called this Weber integral. And this will be quite often utilized in solving your problems. So, we will stop here.